All right, this is probability for JV statistics, and this is text section 4.2. It's actually chapter 13 in the book, hence the notation. And we are talking about independent and mutually exclusive events. All right, so these are really easy to get confused. They're hard to keep straight. So let's go through a few things in item 1 here, okay? Independent and mutually exclusive. Independent means you can multiply, and if you recall, if events are independent, two different events, they have no influence on each other. So then the intersection, this symbol is the intersection, which means when will they both happen at the same time? So a good example of things that are independent would be rolling a dice and flipping a coin or something like that, right? So there's absolutely no impact if you roll a dice and get a 6 and flip a coin and get heads. Those aren't related at all, so they're independent. So then if you want to know the probability of getting a 6 on a die and heads on a coin, that would be 1/6 times a half, 1/12. And you could actually do the sample space on that and figure out there's 12 things, and one of the 12 is both of them occurring. So intersection basically means both occur, okay? All right. Now, when you add things together, unions, the union right here, and union is the symbol U right there. So the probability of A and B isn't as simple as A plus B probability, right? So it's A plus B, and you got to subtract where they both occurred, because where they both occurred is going to be double counted if you're not careful, okay? So that part is, now sometimes that intersection is 0. That intersection is 0 when the events are mutually exclusive, which means they can't happen at the same time. That's a very strange term. It's kind of the double negative one is really hard, not mutually exclusive. It's a double negative, means they can occur at the same time, okay? So let's go through this with that backdrop there. Try to remember this formula in particular. This one's pretty simple to remember, A times B, okay? All right, let's give it a shot here. All right, first thing, 1A, determine if the events are independent or dependent. Rolling a dice, a pair of dice, and getting an even sum, then getting an odd sum. All right, well, rolling a dice has no memory, so those are, every time you roll is independent. Okay, that's easy. B here, randomly selecting one student from this class to move to period 0, then selecting one to move to period 7. Well, the probability changes because of non-replacement. So that's a dependent situation. NFL draft is obviously a dependent situation. I mean, 3 people in a row can't pick a guy, obviously. So that's that situation. All right. And then D is also dependent. This is really interesting. How do you know these are dependent? Well, if the intersection right there, intersection, is their product, then they are independent if it's their product. So 2/5 times 1/4 is not 2/15. So therefore, you know there's some dependency. Even if it's a little bit of dependency, even if they're almost independent, we call it dependent. If they're almost independent, we call it. Anyways, it's got to be exact for the purposes of this class. Again, this one is 0.27 times 0.2, and 0.2 is 1/5. Is that equal to 1/20th? It's not. Okay, so there's some dependence there. And then in F, there's R and there's S. Their intersection is this, and it does work. 0.82 times 0.15 15 is 0.123. So those are independent. That's how you can figure that out. Okay? All right. Now let's talk mutually exclusive or not. Okay? So in 1G here, okay, a fair coin is tossed once. A coin lands on heads, B coin lands on tails. Can those happen at the same time, A and B? They can't. So they are mutually exclusive, okay? Event A is a US citizen, B is a Canadian citizen. Those can happen at the same time. Plenty of people are both Canadian citizens and US citizens, including, I think, Kamala Harris, who I think is both. Anyways, so those are not mutually exclusive, meaning they can happen at the same time. Okay. And then 1I, a 6-sided die is rolled once. A is a 3 or higher. B is an even number. All right, well, let's see here. A is 3 or higher, so that's 3, 4, 5, 6. And then B is an even number. B is 2, 4, 6. Aha! They overlap here. The intersection is the 4 and the 6. So yeah, they can happen at the same time. So therefore, they're not mutually exclusive. Okay? As I always say on these videos, stop anytime, copy things down. I can talk pretty quickly because you can stop and replay it. All right. Now, item 2, understanding and evaluate basic probability principles. Pretty basic. Probabilities between 0 and 1, okay? An example of 0 would be the probability of me getting a date to the prom in high school. 0, it wasn't going to happen, okay? 100% would be probability that the sun rises. That's 100%, okay? If it's not, we're in trouble. And so everything else in between is where it usually happens, okay? Item 2, this is the summation symbol, that fancy looking E, okay? So the sum of all the probabilities in a set is 1. So if whatever's going to happen, the classic might mean, I don't know, a free throw situation where you got a 25% chance of missing both, a 50% chance of making both, and a 25% chance of what did I say? Missing both, making one of two, and making both. There we go, and making both. Okay, so those have to add to 1 because that's the only possibilities you have when a guy goes to the free throw line shooting 2. Okay, and then number 3 here is the complement. Complement is the event not occurring. 1 minus the event that it will occur. That is a crucial thing. Now, we use that a lot of complement stuff. It's pretty easy to understand in writing right there. It's knowing when to use it. I'm going to get some examples here right now. Okay, so let's move on to item 2. We're going to do some calculations of probabilities. No problem at all. All right, a bag contains we got there's the bag. You can read what is in the bag. Find the probability of drawing a blue marble and then a blue marble with replacement. So there's actually 20 marbles there, right? Yeah, 20 marbles. So you end up with 7/20 times 7/20. So it's with replacement. Okay. And then, by the way, that would be dependent, but we're not, really focusing on that. Item 2, a blue marble, then a red marble without replacement. Okay. So if you recall that a blue marble first, that's going to be 7/20 times, and then a red marble, that would be times 5/19. And you see the answer right here, okay, which I've underlined. A yellow marble, then a red marble with replacement, no problem. Yellow marble would be 8/20, then a red marble, 5/20. There's your answer. And then next one, blue, then a red without replacement. No problem. Blue first, so that's 7/20 times red is next times 5/19, and then another red times 4/18, because you're counting down reds as well. Okay, with that replacement. And that's a 4 there, 4 looking for. And you get your answer right there. 2%, not a real high likelihood. Okay, sometimes you get tables, and you'll see that in B right here, you get some tables. Find the probability of representing a girl. All right, girls are right here. So that would be 41/80. So I'll set up for you there, no problem. Next one is a sophomore. That's 10th grader. So it's 25/80. Okay. Next one is a junior boy, both. So it's a two-way table, two-way part here. So a junior, which is 11th graders, and a boy, which should be 15/80, which is about 19%. And then a non-freshman girl. So a non-freshman is, so we got a non-freshman girl, which would be the 10th and the 11th grade girl. So you got to add both of those to get 24 and divided by 80. So it's 3/10 there. Okay. Not too hard, but they do come up. Remember, sometimes these are time consuming. It's not difficult, but it just takes a little time. So the math itself isn't hard, but the getting there can be difficult. What's great about stats is it's all word problems, but you don't really think about it after a while. You're so used to it, which is great. All right, 2C, 60% of voters approved Proposition A and 90% approved Prop B. Find the probability of a voter who voted for both A and B. Okay, and let's say they're independent, voted for both A and B. So 0.6 times 0.9 is 0.54. Okay, item 2, voted for A but against B. Voted for A but against B. Against B would be not B, which is 0.1. And so you see the answer there. And then 3, voted against both A and B. Voted against them, which would be not A and not B. That's the complement. We talked about that earlier. Now we're going to do these things in a tree diagram later. That's coming in another lesson, which will be great. Okay. All right, 2D. From a deck of 52 cards, find the probability of drawing the following. And by the way, there are 52 cards in a deck, in case you don't know. There are 13 types of cards, ranging from an ace to a king. So there's actually 13 different ones. So there's 4 of each, just so you know. So a king and then an ace without replacements. So you can't replace. So the king would be 4 52s, and then an ace, it would still be 4 left, but there's 1 less card left. So not real likely, but in that order. Okay, item 2, 1 card red and 1 card black without replacement. So red is half. You probably could have written half there. And then black is 26 out of 51, and you get this answer right there. Okay. And the next one, a queen and a spade without replacement. A queen, 4 out of 52, and then a spade. So that's with replacement. So 52 is the bottom number both times. You can see I'm kind of putting an arrow to that. All right. So no problem. Those are all pretty simple. All right. Next is item 3. All right, here we go. Some of these are really hard. I starred the ones that are really hard. The ones that are really tough are kind of bonus problems. So I wouldn't worry about them. They're not really test items, but it's kind of extension problems. And again, if you want to do these ahead of time, before you see the answers, that's fine. No problem. Okay. The probability of event A is 73%. What is the probability of event A occurring 4 consecutive times? The event A occurring 4 consecutive times. All right, no problem. That's basically 0.73 times 0.73 times 0.73 times 0.73, which is right there. Okay, here we go. A occurring 2 times, then not occurring the next 2 in that order. So 0.73 happens back to back, then 0.27 happens back to back, okay? And the last one, A occurring no more than 2 times in 6 trials. No, this is tough. No more than 2 in 6 trials. So no more than 2 is it occurs 0 times, then it occurs 1 time, then it occurs 2 times. No more than 2 is 2, 1, or 0. So this is what we've done. So what we've done is this is 6, choose 0, which is 1, by the way. So 0.73 occurs none, and 0.27 occurs 6 times. Then this is 6, choose 1, which is actually 6, okay? And this is 0.73 to the first because it happened once, and the 0.27 happened 5 times. And then 6, choose 2 times that times that. This is a very long problem that I could do and fill up the whole board with the number of ways I could do it. For right now, we're just kind of leave it alone and then keep it simple with what I did there, okay? All right, 3B. The probability of event A is 85%. What are the chances it occurs 6 straight times? Piece of cake. What are the chances it occurs for the first time in the 3rd trial? So it doesn't happen the first time, then it doesn't happen the 2nd time, then it does happen the 3rd time. By the way, for future reference in AP stats, that is called the geometric distribution. Okay, for right now, we're just using it. We're not really getting into it a whole lot. We're just kind of introducing, but it is called the geometric distribution. Then item 3, A occurring at least twice in 5 trials. At least twice is 2 times, 3 times, 4 times, or 5 times. So it means not occurring 0 and 1. So what I'm going to do is figure out the probability of occurring 0 and 1 time, and then do 1 minus that, because it'll leave the rest of them. That's an old trick. But don't worry about this. It's a double star problem. Don't worry a whole lot about it in terms of the test, okay? So I'm going to say it occurs no times or 1 time, and then I'm doing 1 minus that to get my answer, okay? All right. Next, here we go. A die, these ones are good. I really like these problems. The die is rolled 4 times. Remember, the die, every roll is independent. What is the probability that they're all odd? Well, all odd is a 1, a 3, and a 5, which is 3 of the 6th, 4 straight times. Cake. Okay, that's pretty easy. That's 1/2 to the 4th. There's at least 1, 2, at least 1. One of the tricks, when you see the term at least 1, you're going to do 1 minus none of them. That's going to be a trick you're going to learn. 1 minus none, at least 1. At least 1, 2. So let's figure out probability of no 2s occurring 4 straight times. Okay, again, this is 4 rolls. So go 5, 6 to the 4th. Then do 1 minus that, and you'll get at least 1, 2. That's a trick you got to remember. At least 1 is 1 minus none of the occurrences. And none of the occurrences involves the complement. This is a double complement problem if you think about it. Because I need to figure out what are the chances that, okay, a 2 occurs 1/6 of the time. So not a 2 is 5/6. So I'm going to get that number. I'm going to go 1 minus that answer. So that's where you get really into the value of this, okay? All right, not all 3s. Not all are 3s, okay? So 3s, so I need to figure out the probability of getting all 3s. Getting all 3s would be 1/6 to the 4th. It's a double negative, not all 3s, so getting all 3s, and then go 1 minus that. Again, that problem's a little hard to understand just writing it out. All right, slot machines. You go to Morongo Casino or wherever. A slot machine has 3 independent wheels, each having 8 equally likely outcomes. 2 stars, 2 smiley faces, 3 apples, and 1 cherry. What is the probability that all 3 wheels show apples? All 3 wheels show apples, okay? All right, so apples is 3/8 of it, so 3/8 to the 3rd, okay? Item 2, there are no fruits showing. There are no fruits showing. All right, fruits. Okay, what's a fruit here? Apples and cherries. So 4 of the 8 or half are fruits. So no fruit showing would be 1/2 to the 4th power. And at least 1 star. Aha! At least 1. I remember I'm going to go 1 minus none. At least 1 is 1 minus none. All right. So at least 1 star. And the stars are 2 of the 8 are stars, which means not stars is 6 of the 8s. And 6/8, here's my arrow, is 3/4. So I'm going to go 3/4 to the 3rd and then go 1 minus that, and I'll get my answer. Okay? All right. Okay, and that is the end, didn't realize that first, of section, what are we doing here? Section 4.2 or chapter 13 of probability. Thank you very much.